Continuing from the last video, so variation of parameters, deriving the formula for second order homogeneous solutions y1 and y2, we made this guess that y particular is y1 times an unknown function u1 plus y2 times an unknown function u2. And we also made another equation to go with y1 and u1 and u2. We said that y1 times u1 prime plus y2 times u2 prime equals 0, which in the end, when we plugged in the particular solution with into the original difference equation, ended up giving us this other equation to satisfy. And now we have two equations and two unknowns. And it's really nice because we don't have u1 and u2, we only have u1 prime and u2 prime in both these equations. There is no just simple u1 without a derivative, and there's no u2 without a derivative. So two equations, two unknowns, we can actually write this as a matrix equation. So you can write this as y1, y2, y1 prime, y2 prime, times unknown functions, u1 prime, u2 prime, equals 0 and g of x. Right, we are given y1 and y2, and this is the Wronskian. And what's going to end up happening is we can solve this equation for u1 prime by itself and u2 prime by itself. The way that you do that is using this thing called Cramer's rule. The solution to this linear algebra problem is actually equal to, let's see here, u1 prime equals negative y2 times g of x over it's the determinant of this matrix here, but the determinant of this matrix is also the Wronskian. So it's just the Wronskian of y1 comma y2, and we have u2 prime is equal to y1 times g of x over the Wronskian of y1 and y2. This comes from Cramer's rule. It's not the easiest thing to prove, but the negative sign is actually from the u1 prime being in the top of the vector, and then this is a positive y1 g of x because u2 is the second element in the vector. And so we've actually come up with pretty nice expressions for u1 prime and u2 prime. It's all in terms of things we know. We know what y2 is, we know what g of x is, and we know what y1 and y2 are, so we can compute the Wronskian. So same thing for u2 prime. We know what y1 is, g of x is, we know what the Wronskian is. So we can actually solve both these. And so what we can do is we can say, well, okay, the integral of u1 prime dx is going to equal u1. The integral and derivative essentially cancel out. But that's also going to equal the integral of negative y2 g of x over the Wronskian of y1 and y2. And then same thing for u2. If we integrate both sides, the function u2 is equal to the integral of y1 g of x over the Wronskian of y1 comma y2. And excuse me, I forgot my dx there, and there's a dx. So now we actually have expressions in terms of all known things for u1 and u2. We can go back to y particular, and we can plug in those expressions. So right, y particular was y1 times u1 plus y2 times u2. Well, if we plug stuff in, and I think I'll do it in 2 lines here, that's y1 times indefinite integral of negative y2 g of x over the Wronskian y1 comma y2 dx plus y2 times u2, which is indefinite integral of y1 g of x over Wronskian of y1 comma y2 dx. And one last bit is if we take out the minus sign from the first integral, it's negative y1 integral y2 g of x over the Wronskian y1 comma y2 dx plus y2, fix that plus, indefinite integral y1 g of x over Wronskian y1 comma y2 dx, which is the normal way we see the variation of parameters formula with that negative out in front. And that's the end of the derivation. So it's kind of it's a little dissatisfying because it's based on these two assumptions, this y particular equals y1 times unknown function u1 plus y2 times unknown function u2, and then a second assumption, y1 u1 prime plus y2 u2 prime equals 0, which leads to another equation when we plug everything in to the original ODE, this y1 prime u1 prime plus y2 prime u2 prime equals g of x. And just miraculously, everything gets simplified. There's a way to solve for this. The equation isn't too horrible, but you're able to actually get an equation for the particular solution. And we got rid of u1 and u2. We could replace them entirely with things we know. So that's the end, and that's how variation of parameters worked. And hopefully it gives you some sort of piece to know how someone came up with that.